All right, everybody. Testing 1, 2, 3. Y'all say it looks good, sounds good. It looks like we're back online, so it is great to be with you for another edition of Virtual Trivia Tuesday. Hello, everybody. Welcome to the show. This is Science Trivia with the North Carolina Museum of Natural Sciences, and I am your host. They call me Quizmaster Chris, and it is great to be with you for another edition of our program. This is episode something like 205. That means lots of trivia questions in 205 editions of this game. And guess what? I've got 16 questions more for you. That's right, 3 rounds, 5 questions each, bonus question at the end. Each round has its own topic, theme, or a loose association of words that bring those questions together. So you've got 3 rounds, 3 opportunities. Maybe you don't know much about round 1, but you'll know everything about round 2, or maybe you'll know nothing about either rounds 1 or 3 and you'll know everything about round 2, or any combination therein, or maybe, just maybe, you'll know everything about all 3 rounds. However it goes, we're here to have a little bit of fun. We're here to play trivia and talk science, because science is my favorite thing besides pizza, and maybe it's your favorite thing besides pizza too. So, for today's game, let's get into it. There's a very special announcement to be made at tonight's game, because last week we didn't play trivia, and the week before that was the last and final game in the month of October, which capped off our Virtual Trivia Tuesday tournament. Brr, 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 brr. And I have the final results from trivia. That's right, it is time to name our Virtual Trivia Tuesday tournament winners. I hope you're ready. I hope you're excited, because as had happened every single game in the month of October, the leaderboard moved around, flipped here, flipped there, flopped everywhere. And so I'm very excited to have the chance tonight to unveil tonight's winners. If you're ready for them, here they are in 3, 2, 1. Boop, 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 boop. Boop, boop. Coming in bronze position in our trivia tournament, it's Team Piranha Poodle. Yay! Clap, 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 clap. And then coming in second place and winning our tournament silver medal, it's Team Moonlight Bulb. Yay! Clap, 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 clap. But then coming in first place, not by that many points, but doing a fantastic job, it's Team Silver Eagle. Woo! Wow! Houston, we have a winner. So, there you go, everybody. Congratulations to our first, second, and third place finishers. Look, here's what all of y'all need to do. If you're Team Silver Eagle, which apparently includes Team Erla over there in the chat, and you're Team Moonlight Bulb or Piranha Poodle, you need to send me an email at christopher.smith@naturalsciences.org and tell me you were one of the winning teams, and then I will hook you up with your fabulous prizes. Now, I'm sure everybody's curious about where they landed in the scores, so I'm going to go ahead. I'm going to drop the leaderboard up here on the screen for you, where you've all got a chance to maybe... It's small type, I know, I apologize, but there was a lot of players in the game, and I wanted everybody's name to make it up onto the screen. Whether you played one game or all 5 games, I want to thank you so very much for participating in the tournament. I hope that was fun. We'll probably do it again. I thought it was kind of cool, just keeping track of everyone's scores, and I don't know, it added a little bit of fun to the game. Plus, the winners of the winners of the tournament are going to get some fantastic prizes in their mailboxes, including tickets to Journey to Space, the museum's new special exhibit, and other exciting space-themed and museum-themed prizes. I'm just going to put together grab bags of some of the best stuff from the museum. So you'll have an opportunity to come and see our new special exhibit, Journey to Space, as well as just some fun stuff to show off that you just love the North Carolina Museum of Natural Sciences almost as much as I do. So, congratulations, everybody. Thanks for playing. Let's get into tonight's game, because that's why you're all here tonight. Here is your game pin to join the Kahoot for this evening's game. If you've played trivia with me before, you know what's up. If you happen to be new to tonight's game or haven't played in a while, just follow the instructions that you see on your screen. Go to kahoot.it on a mobile device or another browser window on your computer, and then type in that game pin. You'll go through a few screens where you will create a team name. The game will make one for you. Just follow the prompts on your Kahoot device and screen in order to advance. And then you should see your team name show up here on the YouTube. And then we'll get into it, and it'll be trivia time. And I'll ask trivia questions. You'll submit trivia answers. And with any amount of luck, it'll be a good time. And I have to apologize to everybody too. So the museum's website is functioning unless you're an admin, and that doesn't work out so well. So I probably wasn't supposed to tell you all that, but there's just a little there's a hiccupy thing with our website calendar. So I went into add the trivia events to our website, and the website just kind of hiccuped and spit me back out. So I still work here. I still have access, but they're working on it diligently. The best and the brightest are trying to figure it out and get it up and going again so that we can add our events, because that's the only thing that's kind of hiccupy is adding the events. But they're working on it. We'll be back soon. In the meantime, if you've played trivia with me anytime in the month of September or October, you got an email or two from me today letting you know what's going on. And as far as I know, everything the links are right, and all of that. So, sorry, apologies, but thanks for being here. Thanks for playing. 14, 15 teams are logged in for tonight's game. That's fantastic. I love it. Yeah, I take, especially because of, Ken's asking, what's the deal for no custom names now? The deal is that in tonight's game, because of this link issue that I had, where I put the wrong links in the wrong emails and all of that kind of thing, I made this YouTube video public, so there might be a bunch of people playing who are in tonight's game who just found this YouTube live stream because they just happen to be subscribed to the museum's YouTube channel. Wave at me if you're here. You're just like, oh, I got a notification that the museum was live on YouTube, and I came and checked it out. So we're doing family-friendly nicknames using the Kahoot platform to take care of it tonight, because there could be people that I just don't know yet who are in the chat who are going to play trivia fantastically, but I don't want there to be an opportunity for anyone looking to cause problems in the stream. I know we're live on the internet and we're public on the internet for tonight's game, so I got to look out for things like that. And look, I want everybody here to have a fantastic science trivia experience, and that goes, the chat's going off. I like it. We're having a great conversation. We will have great chats about tonight's science as well. But please don't spam my chat. Y'all know the rules. Y'all know how to be good digital citizens. So that's what we're going to do. Okay, we've got 18 teams ready in tonight's game. So I think we should get into it. Of course, the instructions like the game pin and the link will stay on the screen in case you need it for any reason. But let's go ahead and play a little virtual Trivia Tuesday. Okay. Here we go. What's happening here? There. That's what I need. Okay. Sorry, everybody. I don't know what's going on. My screen just went all over the place. Okay. Sorry. I'm having all kinds of issues tonight, and I don't know what's going on. Okay, we're ready. Let's go. Woo! Okay, round one is called It's Musty in Here. Round one is going to be all about these fabulous furry critters that you might know and that you will certainly fall in love with, the mustelids. That's why it's musty in here. Question number one, what is the smallest true carnivore on Earth? Is it the black-footed ferret, the long-tailed weasel, the least weasel, or the short-tailed weasel? One of these is the smallest true carnivore on Earth, very specifically the smallest true carnivore. But it's one of these critters right here. How did we do in our top 5? Or how did we do across the board here? I saw the number 5, and that's what I went with. 8 teams got it right. The correct answer is, in fact, this little guy right here called the least weasel. Oh, like Team Selena over there said, oh, is so cute, is precious. These little friends right here, though, are not pettable at all. You don't want to be around one of these. The least weasel does not grow more than 10 inches long, including the tail. So the body from the tip of the nose to the base of the tail might only be like 5 inches long. And then they can have a 3, 4, 5 inch tail. But then, and they only weigh between 1 and 3 ounces, depending on whether it's a male or female. Males tend to be a little bit bigger, I believe is what I saw. But these little friends right here are ferocious. They have one of the strongest bite forces compared to body size of any animal on Earth. Okay? For a comparison, for example, human bite force is like 84 pounds or something like that. And these guys have 150 pounds of bite force. They are strong, powerful little critters. Mice tremble at the mere thought of a least weasel. Sturdy Wildcat is on the top spot, a few points ahead of Balanced Alpaca and Melodic Dragon. Proud Goat and Cute Glider are in 4th and 5th place. As we look to the next question about mustelids. What is the scientific term for a weasel species with a long, thin body type? Are they called musclymorphs, aquamorphs, mighty morphs, or skinny morphs? Jackson wants to know if it's more or less than a chihuahua's bite. I believe that for the amount of force delivered relative to body size, the least weasel has a chihuahua beat. I have not seen the numbers for a chihuahua exactly, but I would guess, given the different lifestyles that the least weasel and a chihuahua lead, that the least weasel probably has them beat. Least weasel is like one of the strongest bite forces relative to body size in the world. Which is impressive because they're only 5 inches long, up to 10 inches when you include the tail. Okay, time is up on this question. How did we do? Oh, looky here. I don't get to ring the cowbell of rightness for this question either. 5 teams got it right. The correct answer is they're called skinny morphs. Isn't that the silliest scientific term you've ever heard? There's 3 types of mustelid, which includes the weasels. But there's 3 types of body types that they recognize. If the animal in the musty family has a body type like this one, long, skinny, really good for diving down burrows and chasing mice and other rodents, then this is called a skinny morph. Picture a badger or a honey badger or a wolverine, right? Real big, kind of like long face and kind of longer body, but real big and thick. Those are called, guess what? Muscly morphs. And then aquamorphs refers to the mustelids that are aquatic. That includes, for example, the river otter and the sea otter. Those are the aquamorphs. The skinny morph is the correct answer here. Just a great word all the way around. Dynamic Raccoon takes the top spot with that correct answer, and Team Proud Squid should be proud. They picked up points and got up into the top 5 with that one. Oh my gosh, Adric, are y'all on did I see y'all are on vacation? Are you playing trivia like from Walt Disney World Resort? I mean, I'm flattered that you would play trivia while on vacation. Thank you so much. Hope you're enjoying it. Have a great time out there. Okay, next question. What is a weasel's favorite part of its prey to consume? The brains, the heart, the liver, or the wings? What is a weasel's favorite thing to eat when it catches and kills prey? 40 seconds on the clock. I thought this might be a tough question, but the correct answer, only 2 teams got it. It's the brains. Yeah, wild, right? I won't pull that photo back up because it's a least weasel, again the tiniest one, that has hunted and killed a mouse that probably weighs more than it does. That's how ferocious a least weasel is. But their hunting strategy is to use a mouth full of extremely sharp needle-like teeth that can bite down with one of the strongest bite forces of any animal on earth, straight to the neck and straight to the skull, and actually either get the jugular vein and have the animal bleeding out, or to bite through the skull and kill the animal that way. Probably depends on what they caught. And then they will drag the dead mouse, mostly mice is what they eat. They will drag the dead mouse back to a burrow or a hiding spot or a hollow log where they're hanging out, where they feel safe. And one of the very first things that they will munch on is the brains. You might remember from playing trivia a few weeks ago, the brain is actually mostly made of fat. So it's a very good source of calories and energy for these animals. So they'll eat the brain first, and then they could actually leave that prey item for later. In fact, least weasels have been known to store up to 50 carcasses in caches and come back and munch on them later. So they're kind of hoarders when it comes to their food, but you know, you need to have some snacks saved up for in case times get a little lean. Here's what happened to the top 5. Team Proud Squid moved up into 2nd place now. Excellent job with Team Classy Possum finding 5th place by getting that correct answer. The 2 teams that got it right. Good job. Here's your next question. Let's see how much you know about all the weasels. Which weasels indeed have a black tail tip? If you can pick one of the ones that's correct, you'll get points. Your answer choices are the long-tailed weasel, the black-footed ferret, the least weasel, and the ermine. Which of these has a black tail tip? "30 seconds on the clock." Didn't need it. I finally get to ring the cowbell. Here we go. Are you ready? That cowbell means that everybody just about picked up some points on this question. The long-tailed weasel, the black-footed ferret, and a weasel species called the ermine, also known as the short-tailed weasel, they all have a black tail tip, just like this ermine, actually. This is a short-tailed weasel. I believe this is a long-tailed weasel. But yeah, you can see the black tail tip on the tail right there. The one that does not is actually the one that we've talked most about in this round. The smallest true carnivore on Earth, the least weasel, and their tail is just doesn't have the black tail tip. Why? I don't know. Just doesn't. But if you're ever looking at pictures of these, and I'm sure everybody's going to go want to learn a whole lot more about the weasels in North America after this, you'll know which ones you're looking at, or at least which ones you're not looking at by the tail tip. Proud Squid took over the top spot, but it's just a few points ahead of Team Dynamic Raccoon. Cute Glider, Classy Possum, and Sturdy Wildcat round out the top 5. Let's look to your next question in our round. Most North American weasels undergo what color change from summer to winter? Do they go from white to brown, from brown to white, that only the tail tip changes and it goes from black to white, or do they go from a light brown to a dark brown? Color change from summer to winter. What do you think? All right, teams, how did you do? And yay! Cowbell time! Get ready! Cowbell time! Yes, y'all got this one. Well done. The correct answer is that most of these weasel species change color in the wintertime, particularly the ones that live really at high latitudes. There's a lot of snow, and they are active during the winter searching out food. So what do? They just turn white so that they can blend in with the snow. Yep, once the seasons start to change, they shed their brown fur, they grow white fur out, and then when winter is over and the snow is melting, they shed their white fur and they grow in dark brown fur. That way they either can camouflage themselves against the snow or camouflage themselves against the soil and plants easier depending on the time of year. Although, I tried to be slightly tricky, and I don't think it worked because 14 teams got it right. But this photo is of the black-footed ferret. Black-footed ferrets don't actually change color. So they always look like this: the brown bodies, the black mask, and the dark hands and feet, and then the black tail tip. Although the ermines and the weasels also, they don't lose the black tail tip when they do change colors. That's fun. All right, few changes here in our top 5 at the end of round 1. I think that was end of round 1. Proud Squid, Dynamic Raccoon, and Cute Glider held their positions, but Melodic Dragon and Decisive Hawk picked up 4th and 5th place. And Agent Dolphin got the highest climber badge. Nice work. Picked up 3 places. As we look to round number 2. Thinking caps on, everybody. We are switching gears. We're going in the total opposite direction. We just did nature. We just did wildlife, at least. For round number 2, you might be able to guess from this picture. I'm calling it Feeling Basic. Let's see what this round happens to be about. Oh, it's about pH and the pH scale. Here's your first question. What does pH stand for? Does it stand for per hydrogens, protons of hydrogen, parts hydrogen, or negative log of 10 of a hydrogen ion? Per hydrogens, protons of hydrogen, parts hydrogen, or logarithmic function of hydrogen ions. Which one do you think is the correct answer? Less than 30 seconds on the clock. All right, there was the gong. What does pH stand for? Only 3 teams got it right. Oh no, it was a stumper of a question. So I have to admit, learned this fairly recently. Science communicator Chris at the Museum of Natural Sciences only recently learned. Well, let me explain what I learned. Okay, here's the thing. So we knew that the H stood for hydrogen. Everybody knew that the H stood for hydrogen, right? It looks like everybody here knew that. Okay, but what I didn't know is that the P part of the pH is actually a mathematical symbol for a logarithmic function. And a logarithmic function is one that jumps up in scale by 10 with every increment. So like 10, 100, 1,000, 10,000, 100,000, million. Like you make those kind of jumps in the scale. That's a logarithmic function. There's probably a better definition for that, but I didn't remember. So the P is the minus log 10, and then the H in pH is the chemical symbol from the periodic table for hydrogen. So you have a log of hydrogen, and then specifically it's H plus because we're talking about hydrogen ions in this case, and the amount of hydrogen ions in a solution. Right? I didn't know that. That's pretty cool. that's actually where we get pH and pH scale, and it doesn't actually technically represent words like 10 teams voted protons of hydrogen, even though the hydrogen ions are hydrogen protons. So it's kind of the same thing, but the pH scale references the amounts of those things, and so it's a mathematical function. Anyway, Proud Squid, Agent Dolphin, Super Badger, Dynamic, Super Badger. Ooh, we just did a Mustelid round, and Super Badger's in third place. Dynamic Raccoon and Cute Glider are up there. Here's your next chemistry trivia question. A pH level below 7 indicates that a substance or solution is what? Acidic, basic and alkaline, or neutral? A pH level below a 7 indicates that a substance is acidic, basic, or neutral. Only 3 answer choices on this question. Improving your odds a little bit here. I want to ring that cowbell. 30 seconds on the clock. How did we do? Look at that. You ready? Cowbell time. Good job, everybody. Yes, you don't need your pH stuff. A number below 7. So a number on the pH scale that is a 0, 1, 2, 3, 4, 5, 6, or a 6.9999999 indicates that a solution or a substance is what we call acidic. And once you get above 7, so when you get from 7.000000001 all the way up to 14, anything in that range is what we call basic, or also called alkaline, just depending on kind of like who you're talking to. But a pH of 7, right there, smack dab in the middle, and I mean, honestly, kind of like close to 7 also counts. I know I was being silly with the 0.999s and the 0.001s, but a pH that is right in around 7 is what we call neutral. If you're thinking about acidic, basic, or neutral substances, for example, an acidic substance is like lemon juice, a basic substance is like laundry detergent, and then a neutral substance is water, pure water. Pure water is neutral, pH of 7. Well done, everybody. I explained it, but y'all knew it. Agent Dolphin picked up the most points and took the top spot, 4 correct answers in a row, building off of a climb in the musty round. Classy Possum also picked up some points. Here's your next question. A solution with lots and lots of loose hydrogen ions is neutral, basic, or acidic. So we just talked about the pH scale and the numbering. A low number means acidic, a high number means basic. But which one of those represents lots and lots and lots and lots and lots of loose hydrogen ions? The H plus in our mathematical formula pH. Not quite enough correct answers to ring the cowbell. Dang. But 8 teams did get the correct answer. Yes, this is a thing that I think endlessly will confuse chemistry students for all time. And that is, again, the pH scale is just a logarithmic function that starts at 7. So at 7, we're at neutral. When you head in either direction, you are counting up the number of hydrogen ions compared to the rest of the solution. So the way that it works is when you head down towards the small numbers, when you head down here on the acidic side, that is when we are getting more and more and more hydrogen ions present in the solution, and that is what we call acidic. More and more hydrogen ions pushes us to a lower number. And then, Ken nailed it, once we start heading past the neutral zone and we're heading up into alkaline or basic solutions, that is when we are getting more hydroxide groups, the OH groups, and that makes things more basic. Now, when you get to either extreme of this scale, that is when you're getting into dangerous stuff. That is when you're getting in a whole bunch of loose hydrogen ions can easily grab onto whatever another substance is and rip it apart. Hydroxyls, OHs, can also do the same thing in high concentrations. The the OH compounds can go and grab onto stuff and break it down too. Now they work in slightly different ways because they're different things, but at the extremes of the pH scale, you basically end up with the same result, which is the ability to rip other molecules apart. It's what makes makes your hands feel soapy. Sure, when you're up here in like the 8, 9s, and 10s, you get down into the 14s and you're talking stuff like lye that can just like melt your skin off, quote, melt your skin off. And then you get down over here into the acids like hydrochloric, sulfuric acids, which do the whole like burning, sizzling thing. Ooh. 8 teams got the points on that one. Let's see what happened in the top 5. Agent Dolphin held on to the top spot, but Super Badger and Classy Possum picked up some points to take silver and bronze. Proud Squid now in 4th, but Balanced Alpaca picked up some points and sits in 5th. And Diligent Sea Lion gets the highest climber badge. Nice job. Good playing. Here is your next question, though. Ocean acidification results from carbon dioxide dissolving in the ocean, forming which of these? Hydrochloric acid, calcium carbonate, carbonohydroxylethanes, or carbonic acid. How did we do here? 3, 6, 9 teams guessed the incorrect answer, but 11 teams guessed correctly, which means excellent job. You know I love to see it. The correct answer here is carbonic acid. And you're going like, Chris, why is this a question in around about pH? Because ocean acidification is when the ocean takes up a whole bunch of carbon dioxide. As this little graph here shows, carbon dioxide pretty easily and readily mixes into our oceans. And when all of that carbon dioxide mixes into the oceans, it joins up with seawater and it creates an acid, right? So the CO2 grabs onto the H2O and you end up with carbonic acid. Now, carbonic acid doesn't last very long, so it very quickly it turns into hydrogen ions and bicarbonate. The increase in the hydrogen ions, what did we just learn? Drives the pH of the ocean up. So we're changing the chemistry of the ocean and in the process making it more acidic. 11 teams got that one correct. Let's see if it did anything to the top 5 here. Classy Possum has got 5,571 points. Agent Dolphin, 5,371, only 200 points behind. Easy single question guess there. Proud Squid, same deal. Super Badger, Proud Goat, holding on. It's any team's game, really. And Classy Possum, though, on a hot streak. That's how you do well in these games. Here's your next question, though. Many marine animals need carbonate in the water to do what? That carbonic acid quickly breaks down into those hydrogen ions and a byproduct called bicarbonate. Because the ocean is full of carbonate ions, many animals need that carbonate to do what? Use their chemical senses, build shells, regulate their body temperatures, or use their electrical senses. Y'all knew this one, though. Excellent job. Even if you didn't know it, I could sense you were all writing down chemical equations and figuring it out, so good on you. You got it right. Yeah. Marine animals, anything with a shell, from microscopic, little bitty tiny things, all the way out to big things like oysters, clams, and corals. Because carbonate has always, well, maybe not always, but as long as life's been on Earth, the oceans have been full of carbonate. And so life in the oceans has evolved to be able to use carbonate, combine it with calcium, and then they make shell or they make skeleton out of it. But because of ocean acidification and this change in ocean pH towards the more acidic realm, and the carbon dioxide dissolving in the ocean and stealing carbonate and turning it into bicarbonate and the hydrogen ions, we end up with a situation where lots and lots of marine animals, very specifically the marine animals that make up the bottom of the food chain in many cases, end up not having the available carbonate, the resources they need to survive, to build their shells. So they end up having weak shells, or I've seen photos of animals where their shells are transparent because the shell is so thin, because they can't get enough of this resource that they need in order to build their shell, because excess carbon dioxide that humans have put into the atmosphere is getting dissolved into the oceans. This is causing a problem. Then you move one step forward. We talked about the ocean becoming more of an acid because we're putting and filling it full of more of these hydrogen ions. Well, those hydrogen ions then turn around and then start dissolving away the shells of these organisms. So carbonate gets locked away in the bicarbonate, the chemical process from earlier. And then the hydrogen ions, though, have the ability to dissolve the shells away of these animals if they do get them built. So a huge part of the ocean ecosystem is under threat, not even directly because of rising temperatures like we think of global climate change, but the oceans are under attack from all of the extra carbon dioxide we're putting into the ocean, which is why when we think about solutions to climate change, we also have to think about solutions that reduce the amount of carbon dioxide in the atmosphere overall. Just getting the temperature down won't do it. We have to do something about the CO2. Classy Possum is in the top spot. Agent Dolphin, Proud Squid, Proud Goat, and Sturdy Wildcat make up our top 5 as we look to round 3. Hope you're ready for it because we're switching gears all the way again. We did wildlife, we did chemistry, and then a little bit of wildlife. But now, for round 3, we are headed to space with a round I'm calling It's Dark in Here. Here's your first question. What is the term for invisible matter made of unknown particles but that exhibits gravity? Is it imaginary mass, dark energy, the great beyond, or dark matter? Okay, what's happening over here in the chat? I haven't checked in too fast. Ken was helping us explain pH and ocean acidification. Excellent work. Cleopatra bet Mark Antony that she could host the most expensive dinner at the dessert. She dropped a huge, priceless pearl into red wine and drank the dissolved solution, and she won the wager. Cleopatra was apparently a pretty smart person. Knew what was up. Probably didn't taste very good, though. I feel like drinking that much calcium carbonate and that it probably wasn't much fun. I mean, do what you got to do to win, right? 18 teams got this question right. Did anybody get it wrong? Oh, 2 teams said that it was the great beyond. But the correct answer, bless the 2 teams that said the great beyond. But the correct answer is dark matter. Yes, dark matter. Dark matter is the stuff that scientists have observed out there in the universe. We know it's there because we see the gravity of it. We see the effect of this stuff out there because it exhibits gravity, but we can't see it. So dark matter doesn't interact with electromagnetic radiation, light, in any way that we can observe as of yet directly. And so the only way that we know that the dark matter is there is the effect of its gravity that it has on other stuff around it. So it's mysterious. Scientists have still managed to find ways to study dark matter and to try to learn more about it and figure out where it is and how it is. But it's kind of hard when you can't see it, which is why it has the name dark matter. Classy Possum, Agent Dolphin, Proud Squid, Proud Goat, Disturbed Wildcat hold on to their spots. 6 players that are on a hot streak. 3 correct answers in a row. Here's your next question for It's Dark Out Here. Dark matter was theorized to explain discrepancies in the rotation speeds of what? Galaxy clusters, individual galaxies, rotating stars, or planetary orbits. Dark matter was theorized to explain discrepancies in which of these phenomena? Galaxy cluster, rotation speeds, individual galaxies, rotating stars, and planetary orbits. No cowbell for this question, a tough one indeed. But some of the earliest work on dark matter goes back to the 1930s to a guy named Fritz Zwicky. And Fritz Zwicky was a Swedish-American astronomer who was looking at telescope data from the time of galaxy clusters, specifically the Coma galaxy cluster. And he saw that the way that these galaxies were moving around one another, given the mass of those galaxies and how much gravitational pull that they would exert based on all of the matter of those galaxies, everything in them that they could calculate up, those galaxies should have been flung off into the far reaches of space. They're moving fast enough and they're big enough and they don't have enough gravity on their own to stay close to one another. So something has to be holding all of these galaxies together in a cluster. And everything that they could see did not account for the right amount of gravity. So he said there's got to be something out there that we just can't see. 1930s, the rotation speeds of galaxy clusters and Fritz Zwicky is where we first get started. It's kind of a theory. I mean, we'll get into it. Classy Possum, down to Proud Squid. Nice job, Proud Goat. Started Wildcat, picked up some points. Excellent job, but that question was a combo breaker for a few teams. Don't worry, there's questions left. You can get back up there. Which American astronomer confirmed the existence of dark matter in the 1970s? Was it Annie Jump Cannon, Nancy Grace Roman, Vera Rubin, or Henrietta Swan Leavitt? Which American astronomer confirmed the existence of dark matter in the 1970s? By my count, you still had 30 seconds on the clock, but the gong has rung. The correct answer is Vera Rubin. Vera Rubin is it, yeah. If you haven't heard of Vera Rubin, and 8, 9, 10, 11, 12 of you have not, it seems, go read up about this incredible person. So, the Swedish-American guy in the 1930s sees this phenomena with the galaxy clusters doing their thing. And then, in the 1970s, Vera Rubin, a brilliant astrophysicist, brilliant astronomer, is looking at individual galaxies. Specifically, she's looking at the speeds that stars on the outer edges of galaxies are going around, right? Because you see a galaxy and everything's spinning and everything's rotating around the center of a galaxy. And she calculated that those stars are going so fast that they should be flung off into the farthest reaches of space, that if you calculate the gravity of all of the matter that you can find in a galaxy, there is not enough for it to hold on to those stars at the edges moving that fast, right? If you've got a disk, stuff on the outside is moving faster than stuff on the inside, right? And so, because it's trying to keep up. Did I say that right? I don't know if I said that right. Anyway, the stuff's moving so fast it should be flung away, but it's not. It's staying attached to the galaxy. Where is the thing that has enough gravity to hold those things, to hold on to those things? So, Vera Rubin did the work, did the calculations, and more or less sort of like, I say here, confirmed the existence of dark matter, confirmed that there is a mysterious force at work in the universe that we cannot see, whose gravity is having a profound impact upon the galaxy. Upon the, not even the galaxy, on the universe. Gosh. If you actually, I'm going to go back because I didn't, where's this? Here we go. Right? So here's a more modern take on it. The blue dots, that is, the galaxy center is the GC. And when you add dark matter into the system, notice how everything stays in orbit. If you take away dark matter, that graph there on the right, see how everything just kind of gets flung out? There's not enough gravity there to hold on to everything. And so stuff on the outside, the farthest reaches, is just gone. Okay. I'll get back to it. Here's your next question. What effect of dark matter can scientists observe to infer its presence? An effect of dark matter that scientists can observe to infer, guess at, its presence. Black holes, supernova, general relativity, or gravitational lensing. Which one of these could be an effect of dark matter that scientists can look for to help learn more about it? 30 seconds on the clock. 25 seconds. Oh my gosh. 20 seconds. Oh my goodness. Get your answers in, folks. Don't miss out. All right. Only a few seconds left in this question. Sounds like gunslingers from the 80s. Yeah. Oh, I didn't even go into what... all four of those names, by the way, those were all American women who were astronomers and astrophysicists in the 20th century. 20th century? Yeah, pretty sure. All in the 20th century, who most of them did not receive credit for their work, but greatly advanced our understanding of astrophysics. Like Henrietta Leavitt, Annie Jump Cannon, figured out like how to measure the brightnesses of stars to calculate distances across the universe. Like, wow, wild stuff, and calculations that we still use today and that built our modern understanding of the universe. Now here is what I'm looking for. 14 teams got this question correct, so it's time for the cowbell. Yes. Okay. Gravitational lensing. This little animation right here does show what's up there. This picture from the Hubble Space Telescope. See those galaxies that are like long streaks around the edges? Those galaxies are not actually that shape. What we're seeing is galaxies that are on the other side, farther away from us than a galaxy cluster, which is closer to us. So there are galaxies, there's a galaxy cluster situated between our view and some galaxies that are even further away. The galaxy cluster, because of all the gravity that it has for all the visible matter and the dark matter combined, is so strong that it actually causes the light coming from the galaxies behind it to bend and warp around the galaxy cluster. So it creates this weird effect of, I've heard it described like you take a magnifying glass and hold it up to something, and at the outside edges of the magnifying glass, you'll see distortions. You'll see things looking funny. And so it's basically the same thing here, except instead of a lens, like a glass lens or something like that, It's actually gravity itself doing the bending. Gravity moving the light around, flowing in different directions. General relativity has more to do with time and the speed of light, less than how the light moves, to my understanding of it. Now, there are plenty of professional astronomers and astrophysicists who do say that maybe general relativity and our theories about gravity are just simply wrong. That we just need to modify Einstein's equations about gravity that are now more than 100 years old, really, in order to figure out what's going on. Like, we need to make some tweaks, we need some new information, and that tweaks to Einstein's gravitational equations will fix our problem with dark matter. Other researchers are out there looking for particles. They're looking for the actual physical thing of dark matter. And in some interviews that I read, some astrophysicists were kind of the opinion that rewriting general relativity and rewriting Einstein's theories of gravity all wholesale, because it would be pretty significant modifications, it seems like, based on what I was reading, that it's actually easier to imagine that there's just a particle out there that just doesn't interact with electromagnetic radiation or energy, and that we just need to figure out a way to find that particle. We find the particle, we found dark matter, and it's not dark anymore. Redoing our entire understanding of gravity, especially when Einstein's equations have held up so good against everything up to this point, seems like that's a bridge that's a little too far, especially when there are so many possibilities that we might want to think about ruling out instead, like a particle, like a dark matter particle. Sturdy Wildcat picked up, there you go. Sturdy Wildcat picked up some points, is now in the top spot. Nice job. 8 correct answers in a row. But here's your next question. Some cosmologists are searching for dark matter, and they're looking for WIMPs. What is a WIMP? Is it a weakly interacting massive particle, a wholly imaginary minuscule piece, a widely interspersed minute particle, or a window into matter physics? Some cosmologists searching for dark matter look for WIMPs, which is an acronym for which of these? Weakly interacting massive particles, wholly imaginary minuscule pieces, widely interspersed minute particles, or windows into matter physics. Correct answer. 16 teams got it right. Look at you all nailing it on this one. Or were my other acronyms just not that clever? Maybe they just weren't that clever. Well, 3 teams were like widely interspersed minute. They liked that one. Thank you, those 3 teams. And 1 team went for the wholly imaginary miss. I appreciate that. Nobody liked window into matter physics. Oh well. They're called weakly interacting massive particles, and there are some astrophysicists, cosmologist people, they are building detectors and sensors to be able to pick up dark matter particles that they have termed WIMPs, weakly interacting massive particles. Weakly interacting because they don't interact with anything that we know of besides having gravity, so they're weakly interactive. And they have mass, or we assume that if it's a particle, that it has mass and that we can measure it. There are researchers at the Sanford Underground Research Center, I think is what it's called, Sanford Underground. And they actually did experiments, actual physical experiments deep underground, and they were able to narrow the range of masses for which we would need to look. So they did experiments, and they were like, okay, they ruled out a bunch of heavier masses for these particles and said, okay, we don't need to look for a particle within this range now. We're looking for a particle in this much lower, lighter range, less mass. However, the universe is full of neutrinos, whole other thing. Maybe we'll get into it in another edition of the game. Neutrinos are extremely low mass. They're everywhere. And depending on the mass of a WIMP, we may never find them if they're out there matching the mass of the neutrinos. So who knows what's going to happen? It's totally new science. It's cutting edge stuff. And so much of it, even right now, is mathematical equations. At the same time that cosmologists are looking to the outer reaches of the universe at things like gravitational lensing to try to learn more about it. And there's even a space telescope named for one of those woman astronomers, the Nancy Grace Roman Space Telescope, that's going to be launched in the next 2 or 3 years, that is going to be out there to look for dark matter. Team Agent Dolphin picked up some points, moved up into second place. Proud Squid, Proud Goat in third and fourth, with Classy Possum sitting down there in fifth. Sturdy Wildcat holding on to the top spot, with Glowing Rabbit on a hot streak of 7 correct answers in a row. But the blue alien with a soccer ball and a metallic suit means it's time for the bonus round. Here's your last and final question of the game. What percentage of the universe is believed to be dark energy? Pick a number between no percent and 100%. How much of the universe is what's been called dark energy? Closest to the correct answer gets the most points. The further you are away from the correct answer, the fewer points you get. This could make or break your win in tonight's game. 30 seconds on the clock. There goes our slider. It's headed up to 68% is the correct answer. How did teams do? We got one team that said 67, 64, 70%. A lot of teams said 75%. Anybody say high numbers? What about low numbers? I'm just checking down here. Not a whole lot of guesses for the low numbers. Good. I like that. Y'all been keeping up with your astrophysics research, it seems like. Y'all got pretty close to the correct answer of 68%. Yeah, we say scientists believe that 68% of the universe is made of this thing called dark energy, which is even more mysterious than dark matter. Again, it's dark because we can't see it. The only thing that we know about it is what it is doing to the universe. 27% of the universe, 27% of the universe is dark matter. And then the remaining, 5% or something like that. Your remaining few percentage points that make up the pie chart of the universe is the stuff that you can see, the stuff that we know about, that includes you and me. Dark energy is weird stuff, right? You've probably heard the universe is expanding. Dark energy is the stuff that we believe is making the universe expand. Based on Hubble's research and the Hubble Space Telescope stuff that we learned. So dark energy, mysterious, and people are trying to work on all of that. The Roman Space Telescope is also going to be out there trying to learn about dark energy. We're going to figure out what's happening out there in this universe. We're going to crack this code, and it's going to be super exciting, and I hope I'm around for it. It's time to see tonight's winners, everybody. Here we go. Tonight's bronze goes to Team Agent Dolphin. Tonight's silver goes to Team Proud Squid. But tonight's gold medal goes to Team Sturdy Wildcat, who did a fantastic job. Dominated those last few rounds, knew their chemistry, knew their space. Excellent job, of course, to all of our teams. Y'all did a fantastic job. We went from the smallest carnivore on the planet all the way out to the biggest gravitational forces in the universe. So quite the game of Virtual Trivia Tuesday. Wow, how about it? Okay, let me remind you, if you were one of those teams, Silver Eagle, Moonlight Bulb, or Piranha Poodle, that won our trivia tournament from the month of October, make sure you send me an email, christopher.smith@naturalsciences.org, okay? And then I'll coordinate getting you your prize packs for winning. tickets to come see Journey to Space here in downtown Raleigh, and some cool museum swag. More swag for first place, less swag for second and third place, but you all get some fun stuff in the mailbox to you just for playing Virtual Trivia Tuesday. No prizes tonight, but hey, if you won, you can screenshot the leaderboard and then, just have that in your camera roll for forever and ever and ever to prove that you did. But thanks for playing. I hope you had a great time. I hope you have a fantastic rest of your week, everybody. We'll be back here again for another edition of Virtual Trivia Tuesday. Hopefully it'll be up at naturalsciences.org. But if not, just come here to the museum's YouTube channel and look for the live stream. I'll make it a public video again so that it's easy to find, just in case things don't go right for me. Again, just in case. But be well, be kind to one another, stay safe out there, of course. And I will see you all again next Tuesday for some more trivia. Here we go. Say it with me. Bye.